というわけで今井さん、
はい、
我々今どこにいるんでしょうか。
はい、ここはですね、マイクロソフト MSR があるビルらしいんですが、
はい、
今後ろに見えてるものを見れば分かるように、そんなにマイクロソフトっぽいかというとそうでもないという場所で、なんかあまりそれっぽさを感じさせないんですが、要するにですね、はい、僕の目的地です。僕の個人の、
はい、MSR というのがマイクロソフトリサーチという、マイクロソフトの研究所ですね、はい、結構古くからある研究所で、いろんなその基礎研究だったりとかね、してるところなんですけど、今回というかこの番組 AI クエストですけど、 AI がその科学研究をどう変えるか、AI for Science、これ今井さんとの話の中でも何度も出てきた話題ですけれども、今日はその取材でここにやってきました。AI 研究者今井翔太さんと探求する AI クエスト、マイクロソフト本社取材第3弾です。3月の取材の模様をお届けします。今回は AI でサイエンスが激変する巨大研究所マイクロソフトリサーチに迫ります。 AI が新素材を発見する研究について最前線の研究者たちを直撃しました。めったに表に出てこない研究現場の話に今井さんも大興奮。ぜひ最後までじっくりご覧ください。
Any Pokemon hobbies? Pokemon. Where is Pikachu? 今回はですね、僕があまりにもここに来るのに興奮しすぎてしまっていて、徹夜でめちゃくちゃいろんな質問を考えてきて、
やっぱり AI for Science かなり専門的なところでもあるので、とはいえその AI のインパクトが分かりやすいところでもあったりもするわけなので、それがきちっと皆さんにお伝えできるように、
頑張ります。
いろんな話を聞ければと思います。なんとラボみたいなところもね、
いけるらしいので、これもさっきまでやり取りですね、僕が暴走したらごめんなさいと止めてくれということを言いました。
ちょっと興奮してる今井さんを映すのも私の役割だと思っているので、そこもいろいろ見れたらと思うんですけれども、結構その材料ですよね、新材料を開発したいというのに AI を使っているという話を出てきていて、
で特に多分マイクロソフトの人たち今推したいのはサステナブル、環境サステナブルな、素材ですね。温室効果ガスをあまり排出しなかったりとか、あるいはリサイクル可能な素材だったりとか、非常に具体的な研究出すと、回路基板に使われているプラスチックっていうのは基本的にはリサイクルあまりできないんですけども、今日インタビュー取材する予定の人とかは、その辺をなんかちゃんとリサイクル可能にするみたいな研究とかにも精通されている方で、ちゃんとサステナブルな、とこに意識するという点で、その材料科学とかの研究 AI 使っているというやつですね。
あとは新材料、こういう材料が欲しいっていうと AI が探してきてくれるみたいな。
すごいざっくり言うとそうですね。ここからやや研究トークに入っていいですか。
どうぞ。
多分皆さんアルファフォールドは知ってると思うんですよ。AI for Science の一番有名なやつで2024年ノーベル賞を取ったディープマインド、Google ディープマインドの出したやつで、タンパク質の立体構造予測をするやつですね。であれはタンパク質のもう分子アミノ酸配列は事前に分かっていて、でもそれのどういう立体構造を取るか分からないと、一次配列分かってるけど立体構造分からないっていう課題だったんですけども、でそれをディープでポンでアルファフォールドはそのアミノ酸配列入れるとポンと立体構造を出してくれるっていうのが、バイオとかでよくやるやつで、マテリアルはもちろんそういうやつ似たようなのあるんですけども、どちらかというとさっきと逆で、どういう自分がこういう性質を持つ物質欲しいですよということを入力すると、我々条件付けとか言うんですけども、やるとこんな感じの分子構造のものはいかがですかみたいな、
いろんな条件を満たすものっていうのがどれかっていうのを膨大なデータから、
でそうスクリーニングですね。言うていろんなその性質満たしそうだな、これ良さそうだなっていっぱいあるわけなんですけども、さすがに全部実験で確かめるのは難しいということで、ちょっとこれどうなのって AI 入れてみたい、いやこいつは実際ダメだよみたいなスクリーニングしてくれるとかも応用の一つです。
なるほど。というわけでいろんな話を聞ければと思います。今井さんにとっては今日目玉です。
今日は目玉です。事実上僕が今日のために来ました。1時間にどれだけ収められるか。
そうですね。楽しみにいろいろ聞いてきましょう。Okay. Thank you for all your coming. Thank you for your time today. So, I think what's unique about Microsoft is that the company has a fundamental scientific research arm. Which is Microsoft Research. And I think AI and large language models like GPT changes life, work, or even science. And there's a concept called AI for Science. And so could you tell us briefly about what you do and how AI changes it?
So essentially, AI for science is applying AI to the basic sciences, and then from there creating new things with that, and so the engineering part as well. And by the basic sciences, I mean chemistry, biology, physics. And so what our team does is applying those technologies to environmental sustainability. In specific, we look at areas such as energy storage, carbon capture, new kinds of polymers that we can use in the computer industry, and use the AI tools to design materials and to design solutions that add to these areas.
Mm-hmm. And historically, discovering new materials required countless experiments and decades of time. And I hear AI is kind of shrinking down to the days, I think. So what exactly is happening on the front lines of research right now?
I can take that. Yeah, so on the front lines of research, I really think we're at the cusp of a golden age in science right now, because ultimately what we're doing with these new AI models is we're trying to learn the language of science. So what does that mean? That means that we're able to take scientific information and condense it into a model that then we can use to predict new materials. And so that's what we see in these new models, such as MatterGen, MatterSim, SimPoly, which is a model for polymers, and other things.
Mm-hmm. So how does those models work?
So we see a lot of different kind of families of models that have shown up in the AI for science space recently. There's this SimPoly, MatterSim family, BioEmu, which maybe you've heard about on the trip here, where what they really try to do is to let us simulate what will happen at the atomic scale and run simulations that are longer than what we've been able to in the past. And the best analogy I hear for this is that they're like a super duper high resolution microscope that we can apply to problems of interest. So the promise there to be able to take a look at systems that we've never been able to observe before is big. There's this kind of second tranche of models, which is the MatterGen, some of our work that we've done in the past on generative models for polymers that doesn't have quite as catchy a name, where the goal is to explore chemical space. So you'll have some area of materials that you're interested in determining what can actually be visited here. And these models try to let you sample that in a more efficient way. And then kind of the final sect of things is the ChatGPT and other LLMs, where these come in as like a reasoning engine that can power these other tools and allow you to kind of run them and tackle problems at scale.
Mm-hmm. So is this like a ChatGPT moment for science right now?
I don't think we should call it a ChatGPT moment, but I think we should call it a. So there's this phrase, in science that science develops because there's previous science behind it, right? And so you learn from everyone before you. And so there's an American phrase where we stand on the shoulder of giants. And so what I think right now is happening is that with these large language models, we have all these scientific brains, this knowledge condensed together that are, at our fingertips. So that can really help accelerate researchers today.
Mm-hmm. Yeah, that's great. So one more question for me. So Microsoft is basically a software company, but the company is investing so heavily seriously in the physical realm of material science, chemistry, and physics. Why do you think the company is doing this?
Yeah, so Microsoft's a platforms company, and platforms that help both scientists and engineers explore the space of what's possible in chemistry, physics, biology, can be something that enables a lot of people to do their jobs better, to really focus on the science itself or in the engineering itself, and have help from digital colleagues in that work. And so the idea here is to empower scientists and engineers to really focus on what matters for the applications that they're focusing on or for the discoveries that they're targeting, and helping with tasks that are not necessarily using the human to their full potential.
Great, thank you.
Okay. Okay. My question is from the perspective of research. So
He's a researcher in Japan.
okay. First, I want to ask Dr. Bikuerin.
Oh,
Okay. In biology, for example, drug discovery using something like AlphaFold targets the human body and affects human life. So therefore, before AI discoveries can actually enter the practical application, there are many steps unrelated to AI. And so the aspects of these steps are bottleneck. But rather than AI discovery itself, so what about material science? Has a new concrete or plastic materials introduced in your paper? So already reached the practical application phase?
What are the bottlenecks and what
Many
can we do about
bottlenecks?
them?
yeah. So I would say one of the largest bottlenecks we see right now in material science, especially in AI for material science discovery, is this computational experimental gap. And that's the idea of one model cannot capture everything that represents, the physical world. And so when you take that model and you bring it to experimental reality, there's often a discrepancy, which can be overcome with time and with more experiments. And so I think one of the really interesting things that are happening right now in AI for science in general is bridging those gaps by doing high throughput experimentation in a kind of a robotics in a loop type of discovery platform.
Laboratory automation, like
Automation.
Yeah.
Yes.
How is the progress of laboratory automation right now?
I don't do laboratory automation, so I'm not sure.
And absolutely, we see laboratory automation advancing around the world. There's particularly the Accelerate Consortium under the University of Toronto. We've had some collaborators in the University of Liverpool who have like a materials development factory. And so we're excited to engage with the folks at conferences or collaborating directly where we can. But like Bikwan said, we don't directly do lab automation, at least with our group here.
Okay, next question. Did you partner with the University of Washington to borrow the knowledge of researchers there? Or because you need data that only certain laboratories at the University of Washington had? If so, does that mean research in this field cannot be completed by big tech companies like Google or your Microsoft? So while big tech has already dominated most areas of AI with its massive funding, so do you think some areas such as AI for science, for materials, have a chance of success even at the university lab level?
Yes, so I do think, so let me parse that question.
Yeah.
At Microsoft Research, right, we have the opportunity to leverage the AI that we're developing with partners in the academic space. And we see this great partnership between academic research and the research that we do in AI. They bring a lot of, for example, experimental capabilities that we would not be able to do here just because that's not what we're equipped to do, right? And I think we, as Microsoft Research, have this really unique opportunity to do that. And that makes being able to collaborate with these academic groups, we bring knowledge from both sides, because ultimately for AI for science, it's the physical, reality, bringing the AI for science into the real world is really what we're trying to establish. And so we're trying to establish that through a different variety of ways, through collaborations, through Microsoft Discovery, which is our agentic platform that will enable any researcher to bring their data to to use it so that they can accelerate their research.
Okay, thank you.
So you said agentic platform, you use agentic platform for research. So how does agentic AI help your research right now?
Yeah, absolutely. So Bicklin mentioned our partners in Microsoft Discovery, and so we've had the privilege of working with them to kind of test drive their agentic platform. And we've been interested, swinging back to the sustainability angle, in this class of molecules for a long time that would make us better batteries that would store large amounts of charge and could be put in the bottom of a windmill or such to help us smooth out the fluctuation in power generation that you get out of renewables. And so what we've done is we've worked with them to kind of point their tools at this problem and to design some molecules that I'm pretty excited about. And where we are in this stage right now is we have molecules that look good on paper, and we're trying to cross that experimental divide that Bicklin spoke about earlier, working with some collaborators, David Quabi at the University of Yale, to be this experimental partner that can bring in that expertise that we don't have in-house in terms of testing the molecule and realizing it in the real world. So what I think this tool has let us do is it's let us push further down the computational stack than we've been able to in previous tools. So we can ask questions about how the molecule might behave in a system and have the AI system reason about it like a chemist would, rather than like a classical optimization algorithm would, where everything must be very quantitative. And the ability to see this kind of come to life over the past 6 months or so is really, really promising in my mind for the future of not just our discovery project, but other projects that try to design things in silico.
I'm a non-scientist person, so could you quickly walk me through how those AI opens up the potential of material science, like for general people, how we see the new materials coming up will change by those AIs? How should we think about it?
Here, I hope that what we see out of this is for a general person who doesn't care too much about how the materials get made. They're more interested in, is the material here, is an acceleration of how quickly that material can get here. So if we shorten the time that it takes to design a material once a problem has been identified, then this will in turn shorten the time until that problem is satisfied for someone like yourself.
So battery is a good example. Yeah. Okay.
Yes.
And recyclable polymers.
Polymers.
Yes, and polymers.
Yeah.
So batteries, recyclable polymers with particular properties. There's many different types of polymers and many properties that we can expect from them. Solar panels, better materials for semiconductors. There's a variety of different areas where we see the impact of new materials. They may not appear as the material itself, but the effects of new materials with properties that allow them to serve a particular application. We see the application, not the material itself, but we're going to see things getting better faster, I think, as a result.
Right.
I actually have a sample.
Okay.
Yeah.
Great.
So
He gets really excited.
Photo is okay? Photo is okay?
Yes. So when we think about sustainability, and especially around advanced composites, advanced composites are really hard to recycle in general. They're not the typical polymer plastics that we see today, and we have been using AI to develop computationally new polymer compositions that could be used in composites and predict their properties. And so what I have here is a sample of this composite that we, and this was in collaboration with the University of Washington, the Mechanical Engineering Department, and it's amazing actually to see that we computationally designed this and predicted its properties, and we were able to make it and show that those properties did exist in the real world. So yes, if you want to see. So what you're
インタビュー中に写真を撮ります。
So that's one example, right? That's one example. And so you can recycle this. So I also have a recycled version of it, and you can see that the recycled. These are that they're a little old, and so but
Yellowed a bit.
they're yellowed a bit, but this is a recycled version. So you can see that we can remove, for example, the matrix in between, which is in this case, this was designed to be for a circuit board. So FR4 has traditionally a glass weave matrix that you put your resin, your polymer on. And so, so we can show that we can completely disassemble something that could not be done before. And so this is the recycled version. Yeah.
Can we take a look at it? Thank you.
Yeah.
Recycle from this.
Yes, from a larger version.
Whoa.
Yeah.
So what is this material for?
This was
Circuit.
Circuit board,
Semiconductor.
which you can't recycle today.
Oh, okay.
So the plastics, the polymer that you're seeing here, the composite you're seeing here, it's used for printed circuit boards. It can be used for printed circuit boards. And the components are usually mounted on it and are difficult to remove, and also the composite itself is mixed with other materials. It was not designed for being reused. And with this material, what we can do is essentially separate the components much more easily and recycle the composite itself.
How is this impacting the whole sustainability of the data center in the future?
So right now, this is very early research, right? It's a great proof of concept for this. But if you think about data centers or just any electronic device you have, it contains printed circuit boards. And so if we could, for example, improve the circularity of all our electronics, we could reduce e-waste.
Everything is going to be recyclable.
Yes.
Yeah, exactly. Or reused. So the electronics that comes off the board could also be used for other purposes as well. So reuse the electronics, recycle the remaining materials.
And then Jake touched earlier upon the work on these organic redox flow batteries for grid storage. So if you want to just update.
Yeah, absolutely. Without going into it all again, at the high level, what we hope to do with these is to make a kind of large battery that has a lower environmental footprint than something like a lithium battery bank. It is more economically viable for something like use at the bottom of a wind turbine or right outside a data center where you need some smoothing of the power that is going into or out of the grid. And so how this helps us with sustainability is the more smoothing we get, the easier it is for renewables to contribute to the grid, and the lower the kind of embodied carbon and the power that we're consuming at our data centers gets.
Okay. And how do you guys use AI to make this again?
For this one, we developed a model that could take two chemicals, A and B, where A and B can be a really large number of things. And we ran simulations, our kind of atomic level microscope that we were talking about in the past, to determine for some set of A and B, when I put them together, how tough will they be? This is the property we were optimizing for. After we trained this model, we could then ask, all right, for a printed circuit board, I need a toughness or a temperature at which this will become flexible of over 400 degrees Celsius. And the model could tell us, so here's a set of compounds that you might want to go try. This is where that experimental partnership is so important, because now we have this theoretical set of compounds we could try. And so we then went to our collaborators at the University of Washington, who actually made the circuit boards you see before you, and proved that they, A, had the temperature that we were targeting, and B, that they actually could be used in a Internet of Things device, so a kind of small and relatively demanding application of circuit boards.
So how long will it take to get this into the reality?
This is the big question, right? Our work thus far, we've really focused on, how do we get to this point? And what we see is that there's this experimental gap, and we can cross that by working with a targeted partner, but there's also the scalability and the making fit for use gap that would make someone who, consumes a lot of circuit boards want to use our circuit board. And we're hopeful that by applying the new agentic systems to this, we can take on some of the less hard science problems that get in the way of this. Things like, how do we make this the most economical? How do we ensure that the supply chain is viable for this? How do we make sure that we're fitting with the right regulations? This is a direction that we're headed, and we're excited to see how we can cross that gap.
Yeah, great.
Okay, my question for Jake, Dr. Jake. Current AI for science research seems to typically involve multiple people with different background. For me, my background is only AI. So your background is only chemistry, only chemistry. So such as these specializing AI and those specializing in chemistry. Now that AI for science has already brought about a paradigm shift. So is it needed to train people with both AI and chemistry skills from the start, or is it too late, or will such talent be of limited use?
No, it's definitely not too late.
Okay,
like you said, my terminal training is entirely in chemistry, and over the past few years, I've learned to use the AI tools. I've learned about machine learning and these other concepts. So it's definitely something that, particularly someone who's got the scientific training, can pick up and use at a competent level. But what we really hope that we do as a company with things like Microsoft Discovery, with the move to integrating the large language models, is to move things into a language space where it doesn't take someone 3 years of retraining or skills adaptation in order to be able to use all the fancy new tools, but rather they can talk in their natural language as they would talk to another scientist colleague and have the tools kind of executed for them.
This is question for Dr. Karin. Okay, so your research area is new memory, sustainable memory, right? Memory, hardware.
That's where I started,
okay.
Yes.
Okay. So if your research on new memory reach the practical application level, will it lead to the creation of entirely new data center using new hardware? Will it also change cloud data centers such as Microsoft Azure?
So I started, my background is in computer science and specifically computer architecture. So I did start with memories, and that led me to working on DNA data storage, which was the first large-scale multidisciplinary project we did targeting data center sustainability. And from there, environmental sustainability has become a theme for our team here. And the work that we do still today, we pick problems that are tend to be the problems even at the molecular level. They can be used for solving data center sustainability applications like energy storage, as Jake was talking about, printed circuit boards, and so forth and so on. So they're motivated by data center problems, and we're creating solutions that are more sustainable for this application. So it's been a theme. It's not necessarily just memories. I think there's a wide array of different areas where the tools that we're creating can change and improve data centers.
Okay, thank you.
So Dr. Imai is an AI researcher in Japan and working on the AI for science in Japan with the government or other stakeholders. I was wondering so you guys talk a lot about the collaboration with academics like University of Washington. So I think the collaboration between the company and the academia is important to advance the scientific research. So how do you see, what do you think about how you can expand or bring those collaboration framework or those collaboration into the other countries or other regions, or countries like Japan? And so what's your take on that?
Well, we have recently opened a Microsoft research office in Tokyo,
Yes.
and so hopefully it would, you have interacted with them. But if not, the goal is Microsoft Research. One of the activities that we have are engagement with academic colleagues, and so Microsoft Research really tries to foster these collaborations and be part of the community as a whole. And so this is an area that is near and dear to our hearts here.
So my last question would be for future generations of students right now. What do you think about how they get ready for the future where everyone has to make use of AI and do the expand the the maximize the efforts and results in the research environment, in the scientific environment? Well, what is your advice from each of you?
I'd say it's really important to train the skill of learning to learn and leveraging learning to learn quickly and leveraging AI for that, right? And also using critical thinking to make your own opinion about information that is arriving at your ears. But those are I think pretty fundamental skills that are going to be important.
For students in the sciences in particular, I think it's really, really important to have a strong grasp of the fundamentals because so much more information comes past you when you're working with the AI systems, and the ability to be confident in your understanding of the subject matter and be able to immediately tell this is a line that it's put forth that I want to chase up versus this is one that maybe I need to redirect it or provide some more guidance is a critical skill.
Right. Thank you.
And I think just to complement what both Karen and Jake have said is being curiosity driven, because these technologies they advance so rapidly. And so making sure that you're aware of all these changes and understanding whether or not you want to use them in your everyday research or life in general.
Right. Okay. Thank you very much for your time.
Thank you.
Thank you.
To get some, but videos okay?
Video's fine. Oh yes, thank you. はい。ということで、マイクロソフトリサーチのラボにやってきました。何か
This is our hardware lab, and so we do
many figures.
we do quite a
Many
few
hobbies.
things on computers, but we also prototype quite a bit here.
Okay. 3D printer?
Yes.
Oh, okay.
3D printers. There's lathes. There's other prototyping equipment.
3D プリンターがあります。
3D プリンターたくさんあります。
さすが。
And so this is from a project that Bicklin previously participated.
This one?
Those are, yes, environmental sensors.
Environmental sensors?
Yes, yeah. So they're environmental sensors that allow you to have, basically grid resolution of the streets to understand what the particulates are at each street level.
マイクロソフトの今回のツアーの中でさすがすごい研究っぽい話になってきました。
Why is there so many figurines here?
Oh, hobby.
Hobby?
Yeah,
just a hobby.
When you have 3D printers, you just tend to just try to use them as much as you can. So,
Okay.
It's also a good way to exercise creativity. That's something we really have quite a bit in the beauty. So, you see some of the creativity expressed in that way as well.
Any Pokemon hobbies? Pokemon? No? Where is Pikachu?
What are they prototyping here?
Right now, today, we're printing something we call the Busy Box, which is a hand-manipulating task box for robots. We use a robotic arm to try to turn knobs and flip switches and push buttons, things like that.
Okay. Interesting.
Other question. Christopher Bishop is still in Cambridge?
Yes.
Ah, okay.
Because he learned his textbooks.
He is my AI research father.
Yes.
Yes, in many ways, pattern recognition and machine learning.
Yeah, so there was a new edition of the book.
Oh, deep learning and deep learning.
That's right.
This book is just translated into Japanese recently.
Oh, fantastic.
ビショップ先生という、多分別の回でも別のところで喋ったマイクロソフトリサーチの教科書書いて偉い先生がいるんですが、今でもイギリスで現役らしいです。
そうです。
やはりマイクロソフトリサーチの皆さんも尊敬してるような感じです。さすが。
Oh, peppers.
Yeah, we have a few peppers. Sorry, they're not.
It's okay. It's okay.
Out looking at the ceiling at the moment, but they've been very active.
Oh, do you
Active.
project premonition?
Was happier before.
Project Premonition. This is one of the initial prototypes.
For Project
What
Premonition.
you'll see up there is the.
So Project Premonition, did traps to catch mosquitoes, and then sequenced the blood in the mosquitoes on what they had bitten to track spread of pathogens, and that is a prototype of the mosquito trap itself.
Yeah, that's an early prototype, and this is where it is in the current state of its form factor. The trap has to have the ability to attract mosquitoes, be able to determine its gender and species of mosquitoes. After alluring them, then after identification, trap the mosquito, and then we can collect enough mosquitoes to gene sequence the meal, the blood meal, and determine whether or not there's a potential disease outbreak based off the factors of the mosquito in terms of how far they travel after they're hatched. Some species will only travel no greater than 15 miles from where they're hatched, and then using the ability to understand geographically where the location of the trap is, you can put in suppression efforts for a potential disease outbreak. So that's what this project was for.
Okay. This is not related to like material science.
It's related to more of kind of the, let's say, AI for health efforts that we do.
Oh, okay. So what is this lab about, essentially?
So it's any prototyping that Microsoft Research needs to do. We do quite a bit of that here.
Oh, so basically the prototype lab.
Yes,
Okay.
exactly.
ちなみにベッド実験のラボはここにはないらしいです。
あ、ね、なんかそんな感じさっき言ってましたね。So you guys don't work in labs? Really?
We can. We have experience.
Right.
I think that's what's amazing. I think that's what's amazing is that you can have, in a way, AI has been a great leveler, especially these large language models that have been able to help scientists like me and Jake both use AI to accelerate our lab research if we do lab research. So it's been great.
Okay.
Yeah.
Right.
So I think that's it here.
どうでしたか、今井さん。
素晴らしい、素晴らしい。いや、意外となんかメカメカしかったです。コンピューターサイエンスのラボは基本的にメニーホワイトボード。ずらずら。
He said computer science labs just have whiteboards and very like bland.
Well, all of boards are white boards. Okay. 素晴らしい。
And this is a better image of the Project Premonition mosquito trap. Each of the cells
蚊のトラップが。
has essentially it attracts mosquitoes, and then once a mosquito enters one of those cells, it automatically senses it and closes it, and then scientists can collect those mosquitoes for sequencing.
And so if you have enough of these distributed around, you can really map out the spread of a disease that's mosquito-borne.
How much GPU do you typically use for your experiments?
How many?
How many GPU? H100. How many H100?
Depends
Many
on
costly,
what
many costly, extensive.
Depends on the experiment.
Yeah, absolutely.
Okay.
Sometimes it uses like tons of.
Occasionally it uses a ton, but
Oh.
It just depends if you're training a model versus just running inference on that model. Yeah.
Great. はい、今井さん。というわけで、なんか全然違う雰囲気にな
マイク
りました。
ロソフトという空気が全然しないんですが、
はい、実はこれマイクロソフト本社内のなんかツリーハウスというらしいです。
はい、なんか観光名所的なところなんですが、さっきからひっきりなしに人が来てるような気がするんですけども。
なんかいろんな人がね、
はい
チラ見しに来てますよね。
はい、
でもここ会議室として使えるらしくて、
はいはいはい、
普通に予約とかね、ミーティングできるようなんですけど、
はいはいはい、
というわけで、まあそんなところやってきたんですが、
はい、
いろいろ、
はい、
いろんな話を聞いて、
はい、
もうすべての取材が終わりました。
はい、はい、お疲れ様でした。これはちょっと僕の方から中川さんがどれだけ頑張ってるかというのを僕の口からお話しするとですね、いやこれはもう毎回その個別の取材のために中川さんがいろんな機材組み立てて30分ぐらいかけて毎回やってて、で撤収の時をもうすごい頑張って時間間に合うやってくれてて、ちょっとこれはメディアの人に対する僕の見方が変わりましたって言い方変ですけど、本当にお疲れ様でした。僕は脳みそだけ持ってくれる人間なので。
もうそれ十分です。はい。いろんなね、
はい。
カメラ関係は全部自分でやってたので、はい。ちょっと大変でしたけども、はい。まあ、それもまた今後につながるかなと思ったりしていますが、どうですかね、こう、本当に、あらゆるそのビジネス的なところから、はい、そのデータセンターの話とか、量子コンピューターとか、はい、もういろんなものを見てきたわけなんですけど、はい、今井さん印象残ったものって何かありました？
これはまあある意味答え分かってそうな気がするんですけど、はい、まあ MSR のちなみにですね、今回さすがに中川さんがめちゃくちゃその海外慣れしているので、僕割とこれあんまり英語喋らなかったんですよ。多分英語喋ってるシーンがほとんどないと思うんですけども、その僕が唯一もう喋ってたのが MSR のその取材の時
研究者の方々のね、
あれはですね、ラボの中にも入れたんですけれども、まあ、本当にいろんなものを見せてもらった、で、聞かせてもらった、で、なんか実物のものも、見せてもらったと、AI for Science によって、で、具体的にそのマテリアル、AI サイエンス4マテリアルで出てきた素材みたいなものも持たせてもらったということで、いや、研究者としてはですね、やっぱりあそこが一番面白かったのと、あとまあ、そのマイクロソフトの半導体とかを作ってるというか、まあ検査してる施設とかも、で、これはですね、まあ多分この番組の視聴者層結構いると思うんですけども、まあ、いわゆる半導体銘柄の、だから投資的な視点、多分これ僕とかみたいな研究者よりも投資家の人があれ見ると、多分、本当にこの企業のものはこれ使われてるのかみたいな発見とかも、本当に日本企業がですね、めちゃくちゃあったんですよ。
ね、アドバンテストの
アドバンテストもね、キーエンスとかも
いろいろありましたよね。
あったとかで、
伝送のロボットがこうやって動いてました。
なるほど、そりゃ日本株上がるわみたいなのもちょっとあれは思いました。
やっぱり不可欠な、そこもね、AI インフラの中のさらに下のインフラレイヤーみたいなところで、日本企業を支えてるんだなっていうのを感じる瞬間でしたよね。はい。
あと、まあ、それなりに偉い人がですね、まあ、最近 SaaS の人が言われてるんですけども、結構僕の思想と一致してました。要するにエンドユーザーから見たら、なんかソフトウェアの機能だけ満たしたら、そのいいじゃんっていうのは、そんなわけないだろうっていうのは僕結構いろんなところで多分ここでも言った気がするんですけど、まさに同じこと考えてました。
そうですよね。
機能だけじゃねえだろ
う。チーフマーケティングオフィサーの根本さんの話の中でも、
まあ一番偉い人あれに。
はい。出てきましたけども。ひたすらですね、でもその根本さんのインタビューでも僕話したんですけど、プラットフォームカンパニーっていう言葉が、もうなんか20何回出てきたみたいな。はい。数えてないですけど、はい。っていうのと、あとトークンファクトリーっていう言葉。これはデータセンターがその AI のそのトークン、まあ一つ一つの文字というか言語の単位みたいな感じですけど、そのファクトリーになっていくみたいな話で、 なんかその2つが結構、まあ、会社としてはこう言っていきたいキーワードなんだろうなっていうのをね、思いました。
あとはトラストですね。我々はトラスト、信用を売ってるんだみたいな感じのことを野本さんおっしゃってましたけれども、まあ実際マイクロソフトの強み僕はそこだと思います。はい。
大きな企業が頼れる存在みたいな。
はい。これ多分どっかの会で言った記憶がするんですけども、ユーザーがソフトウェアを選ぶ基準というのは、割と機能、まあこれ沼本さんも言ってたんですけども、機能ではないことは結構多くてですね、これ逆にその誰でもコンテンツを作れるようになる、誰でもソフトウェアを作れるようになると、多分逆に加速するというのは、みんなが使ってるからとか、今まで使ってきたからという理由だけでむしろ選ぶことが僕は多くなると思ってます。で、その場合、じゃあその一番長く使ってる、みんなが使ってるのは何かというと、それはもうマイクロソフトなわけなので、
なんか小さい頃から、だって僕が初めて触ったパソコンは Windows95 でした。
なるほど。
今井さんは？
僕は Apple だった記憶あるんですけど。
最初 Apple なんですね。
そうです。家に置いてあったのがそうだったので。
まあ、とはいえみんなワードは使うし、Excel は使うし、やってきたわけですけど。でも、それすらも AI が変えてしまうんじゃないかっていうことが、まあ、いろいろ言われてきて、まあ、どうなんでしょうね。実際、そのソフトウェアの形、まあ、変わらないっていう話もありますけど、
まあ、でも沼本さんは今まで人間相手でサービスやってきたら、むしろエージェントに領域広がって我々としては、むしろハッピーじゃないかみたいなことを。
言ってましたよね。
言ってたので、まあ、意外と中の人は、いい正気なぐらいに捉えてるところもあるかもしれない。まあさすが株価の動きで見たらそう言ってられないかもしれないですけど。
まあでもあれでしょうね。まあ株価って本当に1ヶ月単位とか1週間単位で動くので、まあそこ気にしててもしょうがないっていう。
とは思いますよ。まあこれは実際研究者もそうですけども、研究者から見るとこんな動くわけないじゃんで結局戻ったっていうのは、これまあ僕の多分クロスディグデビューのディープシークの時もそうだったんですけど、多分当時の僕と同じような気分になってると思うんですよね。これはどう考えたら妥当じゃないぞと。
確かに。
はい。
わかりました。最後に、まあ現地にこうやって来てですね、いろんなまあオフィスだったりラボだったり、いろんなとこ回りました。なんかこう、雰囲気だったり、何かこう、体で感じたものって今井さん、何でしたか？
これ最初に本当にどうでもいい話なんですけども、僕基本的にずっと大学にいる人間なので、おしゃれオフィスっていうのを知らない人種なんですよ。なので、マイクロソフトのそのおしゃれオフィスをもうずっと一日中眺めることになって、なんか素直にそっちの方行っときゃよかったみたいなこといやいや思ってます。完全に余談ですけども。
こんなオフィスで毎日働けたらいいな、みたいな。
ちょっとそこ羨ましかったです。
まあ僕も若干感じたかな。でも本当にね、すごいんですよね。なんか、大学のキャンパスよりももっと広い。いや、
こんな広くないですよ、大学のキャンパス。
ですよね。いちいちですね、そのビルとビルに移動するのに、シャトルバスとか、あとシャトルカーみたいなのがあってね、それいちいち待って移動してみたいなことが繰り返しだったんですけど、それぐらい、一回シャトル乗ったら10分ぐらい乗ってるとか普通にあったんで、車で10分で相当じゃないですか。だからめっちゃ広いなとは思います。
そうですね。で、まあ、マイクロソフト来て感じたことの話を戻すと、まあ、さすが大企業というだけあってですね、社会に対して大きな責任を我々持つべきだというのを、もちろんその経営者 CXO とかバイスプレジデントレベルの人が持ってるのはそれは当たり前なんですけども、まあ MSR とか話を聞いてると、割とその末端って言い方失礼ですけども、なんか現場の従業員レベルでもその辺が浸透してたような気がします。まあ僕はまあ研究者なので、その辺をまあ無視とは言わないですけども、結構なんかおざなりというか、っていうかあったりするんですけども、まあそういうこととか僕がなんか触れたりすると、いやいやそこは実はそうじゃないんだよみたいなのがあったりしてですね、なんかさすがこういう世界を代表するビッグテックで働いている人たちはその辺違うなというのを感じました。
はい。いや本当ね、そうやって研究者として、その同じなんでしょう。研究の畑でやってる人たちと話せたのはすごい今井さん。
あれはですね、あれはものすごく面白くてですね、普通に喋りながら、メタラーニングとか
通じ合うところね。
あります。あれは研究者のやりとりでよく、
わかりました。というわけで、まあいろんなものを見てきました。AI クエスト初のロケ、しかも海外ロケ。全部カメラは私と今井さんの手持ちです。ちょっとお見苦しいところもあったかもしれませんが、楽しんでいただけたら幸いです。というわけで次回以降の AI クエストもまたよろしくお願いします。
よろしくお願いします。
ありがとうございました。すみません。